All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be learning about embedded programming in Rust, more specifically, Rust programming for the ESP32, which is a microcontroller that I've been playing around with this for a good like year or two, on and off, doing small projects here and there. I initially started out with using MicroPython for it, but then now since I've been doing Rust for a little bit, so I got give me a second. Give me a second. I opened up my stream on my phone just so I can see the chat. Yeah. Okay. Uh wait, give me a second. Right. Yeah. So now since I've been doing Rust for I don't know, the past couple of months, the past year, I've actually been doing Rust as well on and off, just like ESP32 for the past couple of years. But then it's only this year that I started to get deeper into it and started to actually do things with it. Um, I really should have followed my own advice, which is if you are trying to get better at a programming language, then just do stuff with it. Make shit. Make whatever, even if it's just garbage, just make shit. Because that's the only way that you're going to learn the language and get better at it, and get creative with it. Just making stuff, it helps you explore the language and the various frameworks, libraries, and so on available a lot more, a lot better than if you were just, watching or reading some tutorial or something. At least in my experience, making stuff with the language, it it teaches you a lot more because it gives you something that tutorials can't give you. Tutorials give you like they're good in their own right because they give you knowledge, but the kind of knowledge and experience that you can get from working on projects, you can't get that from tutorials. So yeah, yeah, I I admittedly didn't follow my own advice for a long time, not because I didn't want to, it's just something that didn't occur to me. This is something that I would tell other people to do if they asked me for advice. I would be like, dude, just make stuff. Just make shit. Um Give me a second. Let me just resize this logo. There, better. Okay, anyways, so couple months back, or maybe a year back, I got this idea that hey, I've been doing MicroPython, which is it's a subset of Python for embedded programming. I've been doing MicroPython for ESP32. Why don't I explore if there's any way to do Rust programming for the ESP32? At the time, I didn't know how vast the ecosystem for embedded programming in ESP32 is. But then after I did research, then I found out that holy shit, there's quite a bit of work being done, not just for ESP32, but for other microcontrollers as well. And that's good news for me. And there is to a certain extent official support from Espressif. That's the brand that makes the ESP32 devices. There is like official support from them for Rust programming on ESP32. So I have installed a couple of the tools that are required. One of them being ESP Generate. Give me a second. Yeah. Okay. So I've been I've installed ESP Generate, which is used to it's a tool that helps you generate the Rust project for ESP32 programming. It's gonna I believe it does have a TUI as well. We're gonna explore that. I have looked into it a little bit previously, but I didn't get like too deep into it. Currently, I have Let me show you. If you look at this thing that says kin hang, this is my ESP32 plugged into the USB. And I've installed the tool chains necessary, other than cargo ESP generate and ESP generate, or I think it's ESP flash. I don't remember if I installed ESP generate. Hold on. Yeah, I've installed ESP generate, but what I installed recently was ESP flash, I believe. Yeah, this is what I installed recently. ESP flash and cargo ESP flash as well, which from what I understand uses ESP flash internally. Um, I might need to update my, what do you call it? Wait, give me a second. Yeah, okay. What was I saying? Yeah, I might need to update my ESP generate. I don't remember where I installed it from though. Oh, actually, yeah, I could just do this. ESP generate cargo. Okay, so then I could just run cargo update, right? Is there a cargo update? Let's check. Yeah, okay. Update dependencies as recorded on the local. What? This command will update dependencies in the cargo log. Oh, this might not be for. Yeah, wait, let me. This is for dependencies. What about binaries? How do I. Is it just like a reinstallation kind of thing? Cargo install update binary. How to update a binary installed with cargo install. A cargo subcommand that helps you update cargo subcommands is cargo update. Oh, so it's the same command. Um, just a second. Okay, you can do that, though it will always recompile and install cargo outdated even if you have the latest version. A cargo subcommand that helps you update cargo subcommands is cargo update. This answer is from 2018. To update a binary installed with so-and-so, you can either use the original command with the force flag or leverage third-party tools like cargo update or cargo binstall. You can force a reinstall of a specific package with the force flag, which will ensure you get the latest version from crates.io and will overwrite the existing binary. And then there's third-party tools. For faster installation of precompiled binaries, cargo binstall. Okay, a simple way to update all cargo installed binaries. The update all option can have, wait, sorry, I'm reading this on a different machine. Um, there exists cargo update crate. Does it fit your use case? Okay, all right. Looking at the crate page, looks like the functionality is the desired one. All right. What about integrating cargo update into cargo itself? Um, I'm not a member of the cargo team, so the following are only my 2 cents. Okay, this is from 2021. Um, if you use Nutshell, simply use this script. I'm afraid the cargo CLI API may not be stable enough to guarantee the regex won't break. I understand it's just a workaround, so that should be expected. Okay. Cargo install. Okay, okay. All right, so what I'm seeing is people are giving um all sorts of answers here. There isn't something for updating. That's that's odd. That is okay, let me look at the official Rust page for installing binaries. All binaries installed with so and so. Okay, if you install Rust using rustup and don't have any custom configurations, the default directory will be that. Okay. This does not talk about updating. So I guess updating is just replacing the thing then. So we force the installation, which I don't know if I need to be doing that. Okay, for the time being, what I could do is, um, yeah, let's do cargo install. Uh, actually, wait, where's the F flag? Okay, force overwriting existing crates or binaries. This can be used if a package if a package has installed a binary with the same name as another package. This is also useful if something has changed on the system and you want to rebuild, um, such as with a newer version of Rust C. Okay, this is not mentioning update. You know what? Uh, okay, wait. Let's let me go on crates.io. Wait, ESP generate. I'm gonna look this up separately. Okay, cargo install, ESP generate. Great, awesome. Oh wait, does ESP generate have an update option? Let me look at that. Okay, I don't think it does. Yeah, I don't think it does. However, on crates.io, it's saying the version is 1.1.0. Now let me see what's the version here. Okay, it's not that much of a difference, but we can do it anyways. F and let's say J2. I spelled install wrong. I learned about the J2 thing recently. Recently being like, I don't know, half an hour ago, 1 hour ago. Because I know how to do this in like recompiling when you're recompiling actual Rust code, which I mean, this might also be actual Rust code. I don't know. I'll have to actually, you know what? I should check because it does say compiling here. I should check like what exactly is going on in this case. What is being downloaded first and then compiled? Because that's exactly what happens. It downloads the thing and then it compiles it to build. It compiles a bunch of these different uh, crates to then build the final binary. Where was I going with this? Oh yeah, so I learned how to set the jobs thing, the jobs option, in in the config.toml file, I think it is. So you can within your Rust project you can create a .cargo directory, and within that you can create a config.toml file, and there's various cargo related settings that you can customize in within that file. So if you don't want the cargo build system to take up all of your cores, all of your processor cores, then you can set it to a specific number. In my case, I know that there are 4 cores, and I wouldn't mind it using all 4 cores. The thing is, if the build runs for a while, then those cores are all running for extended periods of time, and they start to get hot. Like it starts to, the temperature starts to rise, and that becomes a problem. Uh, to give you an example of, I don't know how well you guys are going to be able to see it here because there's green screen stuff going on, but there's 4 cores on this system, and 2 of them are going to be used by the Rust build system, and one I think is being used by OBS. Obviously, it's being like the work is being like divided amongst multiple cores by the system itself. So it's possible OBS is using multiple threads which are being spread across multiple cores. But my point is, if I didn't specify J2, which means 2 jobs, then all 4 cores would be sitting at 100% right now, and you would be hearing the fans on this desktop running. Uh, okay, replaced package so and so with so and so. Awesome. So we now have version. Wait, what happened there? Hold on. Isn't? Oh God! Don't do that. Don't. It started to generate the thing. We'll get to that, but just not yet. Oh, it's capital V. Okay. Right. So we have the correct version here. Now, that being said, hold on, let me just confirm that you guys are able to see. How do I confirm that? Let me open up Rusty Rain and see if it pops up. Might not pop up for you guys on screen because these are green. No, this is not being green screened. That's interesting. Yet BTOP gets green screen. It might be the settings that I've done. I don't know. I'll have to look into that. But like you guys don't see any green on BTOP, but then you're able to see the green here. That's anyways. Um, what was I doing? Oh, I think I know why. No, no, I take that back. I don't think I know why. Yeah, yeah. I'm not sure what's the reason why this text is not getting green screened out. But yeah, okay. That being said, I do now know that this is it is being captured. Okay. So I was reading up on the ESP32 on the well the Rust ESP book, and I'm focusing more on no STD. That's no standard. That means no standard library is included. So various features like the heap, for example, and various like printing features that print out to the console, and I don't know, like file system, file IO features and stuff like that. They won't be available. That's not to say that some of that functionality has not been re-implemented in a different way to fit the the features of a microcontroller, but the standard library itself is not in use. So you're going to be doing a lot more bare metal Rust programming. Where was I going with this? I forgot what I was saying. So I've been reading up on this. The book is, I believe it's this one. It's the Rust on ESP book. Yeah, let me show you the preface. So this is for anyone interested in um, ESP32 programming using Rust. They have this very useful book. Um, and the book is divided into multiple sections, or rather, they give you multiple resources. Currently, we are on this book, the embedded. I believe it's this book, right? Hold on. Yeah, the Rust on ESP book. I don't know if this embedded Rust no STD on Espressif is also part of the Rust on ESP book. No, this is a separate book. Give me a second. Let me go back to that. Yeah. So I haven't looked at these two. I'll get to that later on. But it does say that it's a list. These are both lists of resources for various things. But for now, I need to focus on both of these things. Um, I need to get basic knowledge of or foundational knowledge from the embedded Rust book, and then I'm going to move on to embedded Rust no STD, because in the no STD version, they do reference this book, and they'll say that okay, there's certain information here. Like for example, this. It says the Hello World example is basically a project generated with ESP Generate. Templates are already covered in the Rust on ESP book. See generating projects from templates chapter for more details on how to generate a project from the ESP Generate, and understanding ESP Generate for detail on what is inside the template. So there is some information that you do need from this this book, but I'm not going to be sticking with it for too long because I don't plan on doing STD development. I'm going to do no STD. Give me a second. Let me take a sip of my energy drink and hydrate, and then I'll continue reading this. This is where it gets interesting because here they mention the whole like ecosystem. They talk about ESP HAL and various other crates that are involved for various features. So we can read up on this and we can then move on to whatever comes next. Embedded Rust ecosystem integration. I think that's on the same page. Okay, good. So it does go into the tools later on. Then there's ESP configs TUI. ESP config. Did I ever? I don't think I installed ESP config. I don't have that. Let me let me look this up. Give me a second. ESP config, a configuration tool for ESP32 and ESP8266 devices. Is this still is this still being updated? I'm not sure about that. Though I don't see them mentioning that this is no longer in development. Yeah, I don't see them mentioning that it's no longer being maintained. That's fine. We'll find out once. Though, okay, are there like any screenshots or anything? I'm not seeing any screenshots on. Yeah, also the tool itself is not made in Rust. It's made in C, C++. So I'm wondering if somebody eventually made like a Rust equivalent of it to kind of replace its features or replace its functionality. Oh, I was supposed to hydrate and uh, take a sip of my energy drink. Give me a second. I will do that. Okay, all right. Now, if we are going to be doing ESP32 programming on stream, I do need to also show the microcontroller itself, with a breadboard and stuff like that. Just a second. Give me a second. Okay. So, what was I? I forgot. I forgot what I was saying. Let's read this. So, ancillary crates overview. Before going into a detailed description of various packages and concepts for writing an application, it might be useful to have a superficial familiarity with the whole ecosystem, both in the ESP HAL sense and in the broader embedded Rust sense. Okay, ESP HAL ecosystem. The first step in working with the project is to create it. The main way to do this is to use ESP generate. I remember a time when that wasn't the official way of doing it, and I'm glad that now this is a way of doing it. But I do remember, and this was a while back. This was a good, like, I don't know, 2 maybe more years ago. Because they've been continuously improving the ecosystem and the tooling and a lot of like the libraries and stuff. They've been continuously improving all of this over time. So it has matured quite a bit. There's still a long way to go, but it has matured quite a bit since I'd first looked at it, which was a good few like years ago. Where was I going with this? Oh yeah. So I do remember there was a time where using ESP generate was not the official way. And there would be a bit of boilerplate stuff that you would have to do in order to set up a project for ESP32. Okay. Read more about it in the section dedicated to this tool. We are going to do that. Oh, actually, I want to see if that, because dude, I remember, because like, okay, you see this when I typed ESP32, no, ESP generate. See these options that popped up. Similar to this, there is a TUI option. I don't remember if it's in this or it's elsewhere. Yeah, I can't remember if it's in this or elsewhere, because I remember seeing like a proper TUI kind of thing. Okay, you know what? Now that I'm thinking about it, I don't remember if it was on the Rust side or on the MicroPython side. Yeah, yeah. That's no, I think it was on the Rust side. There was like a TUI option. It would give you something similar to what we were seeing here. Um, yeah, something similar to this, but it wasn't just here. It would like take over the entire screen, and then it would, give you various options to choose. Or maybe they've made it so now it doesn't take over the entire screen. Um, I forgot which microcontroller this is. Give me a second. I need to look at the thing. Okay. It says just ESP32. It's a ESP32 Vroom, which I'm guessing it comes under just ESP32. Then we select a project name. Okay, that's fine. So far, there's nothing in the directory. Okay, now we need to read this. Okay, the core crate that ties all work with ESP with Express-if chips in Rust is the ESP HAL crate. Through it, you will be able to perform basic initialization of the chip as well as access drivers for the peripherals available on the chip. The full ESP HAL documentation for selected chip will give you unambiguous information about what peripherals are available and the stability of their respective drivers. Furthermore, if you want to use more advanced functionality of the chip, for example, network and connectivity, this part of the ecosystem is the responsibility of ESP Radio, which combines drivers for the communication protocols available on on one or another of Espressif's products, like Wi-Fi, Bluetooth, ESP Now, and low-level IEEE. I need to look into what that is for. For lower layers, oh, that's for much lower level, much lower than Wi-Fi and Bluetooth and ESP Now, which also I recently I just today I looked into ESP Now. For some reason, I was assuming ESP Now is a separate service that would be running and it would help you communicate. But it turns out that ESP Now itself is also a protocol, and it helps with like device to device communication. And there was this very useful. Okay, this is not a link, so I can't show it to you right now. But like, okay, there's so for those of you who know what the OSI model is, actually, okay, for those of you who don't know what the OSI model is, the OSI model is it's a conceptual model that shows you in layers how your data is transformed from one layer to another to help facilitate the communication. So let's say you are typing google.com, it's going to show you conceptually how the data gets transformed through these various layers. Basically, it's supposed to show you how it goes from your browser or you entering the thing into your browser, going out the hardware of your computer. So like how it goes from being a bunch of bytes to going out of the physical hardware. So it divides the communication into multiple layers to explain how this is happening. Through this, you are able to see like various protocols that are being used, and you're also able to get an understanding of what's going on the hardware level when communication is taking place. Okay, now using the OSI model, they showed that the ESP Now protocol apparently gets rid of a good chunk of the OSI layers, and it facilitates like very low level communication. So like you don't have the higher level stuff like IP, and on top of IP you have TCP running. On top of TCP you have a bunch of other protocols running, and then on top of that you have your application running, which is going to be using this protocol, which is then going to use that protocol, which is then going to use that protocol. None of that happens because ESP Now, that one protocol, it runs directly on like a very low layer, a very low level layer, to where it doesn't need to use any of these extra protocols. I'm guessing that that helps with um, uh, at the very least, it's going to help with performance because there's not going to be nearly as much processing going on to convert from one protocol to another to another. You don't have these multiple layers. It's just this one big layer. Though I'm yet to explore ESP Now myself, they did describe it. They did describe it as like a device-to-device communication protocol, which is great because if I have multiple, I'm assuming, so they said device to device, so I'm assuming it's microcontroller to microcontroller and not microcontroller to computer. Because on the computer, in order to have communication take place, you would need these extra layers. Though it would be interesting to see, like, if it is even possible. Because, like, on the computer to begin with, if you're doing a wireless kind of connection, then you would need there would be multiple protocols like at play there. But yeah, okay, that's something we can explore. Okay, moving on. Uh, for lower layers of communication, I should also look into this. Hold on, the IEEE 84 something something. Isn't this just like uh isn't this just the tech that Wi-Fi runs on? Hold on, let me look it up. What is IEEE 802.15.4? It's an IEEE standard defining the physical layer and media access control for low-rate wireless personal area networks. Wait, that's interesting. Hold on, this is running on the physical layer, but still able to do wireless? Yo, I need to look into this. Enabling low cost, low power communication for applications like IoT, home automation, and sensor networks. It serves as the foundation for protocols like Zigbee and something something, allowing devices to sleep for long battery life and communicate infrequently over short distances, making it ideal for battery operated devices. Okay, I need to do more research on this. And I think I might also need to revisit the OSI protocol. The interesting thing is I've looked into the OSI protocol from the computer standpoint. I've never actually looked at it from the microcontroller point of view, as in how it might be applied from the microcontroller point of view. And this is great because I sometime later after learning about the OSI model, I learned about the IP model, and it turns out that the IP model was built to give you uh, to give you a version of the OSI model, or to give you something similar to what the OSI model gives you, but something that is um, more relevant to computers. Because the OSI model, it turns out it was like a conceptual thing for multiple different architectures, not just computers. So it was very generalized, but like if you wanted to make something that is like specific to computers, you would use IP, as in the IP model. But here, the OSI model, because it's like a very it's like a very generalized model for communication, not only limited to computers. Though technically, I think even the microcontroller would be considered a computer. But like I'm talking about computers that run like Linux and stuff, Linux and Windows and like those kinds of computers. OSI can help visualize that. I need to talk to Gemini about what exactly that visualization would look like. Yeah, yeah. And this would be probably a lot easier to understand as well, because of how low level things are on ESP32, and especially when doing, bare metal Rust programming for ESP32. Like you don't have an OS level, you don't have like a um, how do I say this? You don't have a kernel, you don't have an OS, you don't have a an application that's running on top of the kernel. You don't have stuff like user space and kernel space and stuff like that. I mean, you do have the concept of AOS. There is an OS available, probably multiple, but there is an OS available. It's not the same OS as Linux, but like there is a OS available. I'm doing bare metal though. So whatever programs you create, they're running directly on the hardware. They're not running on another layer. So for example, if you did MicroPython, you would be flashing the MicroPython firmware onto your ESP32, and then you would write your MicroPython scripts and load them onto the ESP32. You won't be flashing the firmware again. You load the MicroPython script onto the ESP32 so that that script can then run on the MicroPython interpreter, which is part of the firmware. In the case of ESP32, it's all running directly on there because it's all running directly on the hardware because it's getting compiled. Okay, all right. Let's continue reading this. But yeah, I need to look into this as well. The IEEE something something. Where was I? Oh, yeah. For more advanced work with chip memory and to use collections from the alloc crate in no STD that require heap allocation, you are welcome to use ESP alloc. A separate chapter in this book is devoted in the book is devoted as words. A separate chapter in the book is devoted to this. Why was that so hard to read? The table below briefly describes all the crates in the ESP HAL ecosystem and their purposes. Okay, so you have ESP alloc, you have backtrace, you have bootloader, ESP IDF. Offers additional support for the ESP IDF second stage bootloader. Yeah, we are not going to be using ESP IDF. That's another thing. Because if you're using ESP IDF, then you would have the option um, for STD stuff, at least from my understanding. But we are not using the IDF version. We are just using like a much more bare metal version. ESP build utilities for use with ESP HAL and other related packages intended for use in build scripts. Then ESP config is a configuration system. ESP HAL is bare metal, no STD HAL for all Express if ESP32 devices. Then ESP HAL proc macros, which is procedural macros for use with the ESP HAL family of HAL packages. ESP LP HAL, bare metal, no STD HAL for low power. I didn't know this was a thing. For low power and ultra low power cores found in some Espressif devices. I should look into that one as well. Um, ESP metadata for Espressif devices primarily intended for use in build scripts. Preempt, which is threading and thread-aware synchronization primitives primarily used for ESP radio. Print line, print and logging functionality for Espressif devices. RISC-V RT, minimal startup runtime for RISC-V CPUs from Espressif. Then ROM-sys, ROM code support. RTOS, this is the OS that I was talking about, that is available. It's not like a full-fledged OS, but like it's an OS in its own right. Scheduler implementation for ESP radio, embassy support for ESP HAL. Okay, ESP sync, synchronization primitives for Espressif devices, ESP storage utilities for Espressif devices, ESP radio, all the communication functionality for Espressif devices, LX, low-level access for Extensa LX processors and peripherals, and then minimal startup runtime for Extensa LX CPUs from Espressif. Okay, the stability of individual peripheral drivers within ESP HAL varies. Refer to the peripheral support section for peripheral stability details. You can find details about any of these packages in the ESP-RS documentation. Then, embedded Rust ecosystem integration. The most popular hardware abstraction layer in the embedded Rust environment is embedded HAL, which provides a number of traits for several peripherals that allow writing HAL agnostic device drivers. ESP HAL implements these traits within its drivers. Okay, so we have embedded HAL that provides a bunch of um, it provides a sort of blueprint, and then ESP HAL implements this blueprint, implements various like functions and stuff from this blueprint. In addition, in addition, various traits, holy shit, various traits from different crates used in the embedded Rust industry have also been implemented, such as RAND core traits for our random number generator peripheral. Wait, I didn't know there's a separate peripheral for random number generation. The ESP32 has an RNG pin. Hold on. I need to look this up. ESP32 RNG pin. The ESP32's random number generator is a built-in hardware module and does not use a dedicated external pin. Instead, it uses internal physical noise sources such as variations within the chip and noise from the Wi-Fi slash Bluetooth RF subsystem to generate true random numbers. You access the hardware RNG through software APIs in the ESP IDF or Arduino frameworks, not by reading a specific GPIO pin. Oh, okay. All right. Okay, as well as embedded I/O traits, which are analogs of STD I/O traits for no STD applications. All right, cool. Getting started. This chapter guides you through setting up your development environment for building applications with Rust on Espressif devices. Okay, Rust installation, make sure you have Rust installed. If not, see the instructions here. Okay, I'm done with Rust installation. Now, I don't know. Okay, to build Rust for Espressif chips based on RISC-V architecture, if you're unsure what your device is, see hardware overview. Okay, let's take a look at this because I do have multiple ESP32s. Um, Wait, give me a second here. Just a second. Okay. Yeah, like I was saying, I do have multiple ESP32s. Some are ESP32, some of them are C versions. I don't know, C2, C3. I have a C3 Super Mini as well. I don't know if I have any of the S versions. I'll have to check. I don't even know which version my ESP CAM microcontroller is. I'm gonna have to look at that. But each of these, they might have a different CPU. Let's take a look at this page. Is this what that thing was leading to? Oh, here. The crates under the ESP-RS organization include support for ESP32, ESP32S, C, H. Yeah, I definitely don't have H. I don't remember if I have S. I do have C. And I have like just a vanilla version. Okay, ESP32 and ESP32S series are based on the Extensa architecture, and RISC-V is for ESP32C and H. Okay, this, by the way, is what an ESP32 looks like. A lot of times you won't have these two things. I'm yet to do proper research on both of these because it seems like both of them can be used, but it's just like a different type of communication. Because it mentioned that one is communicating directly over USB, while the other is using USB to UART. So it takes the USB messages, but then it converts them to UART messages, which would then be understood by the microcontroller, which is generally how your because like if you have an ESP32, most of the times it's going to have one USB port, unlike this one which has two. Um, Generally, what it's doing is using the USB to UART thing, right? But in this case, when it says that one of them does the communication directly over USB, I'm like, okay, how is the did I say conversion? No, I said communication. Um, one if you're saying that one of these is doing communication over USB, then like how is that USB message being interpreted and understood? And like if the other one is USB to UART and this one is just USB, how is like if you're able to just use one of them, then what's the point of the other? That's kind of what I'm getting at. But yeah, I need to do research on this. Oh, you know what? I just noticed something. So it says here ESP32C6 Vroom. Mine, I need to see if there's anything after the ESP32 and before Vroom because what I have connected here is Vroom, but I haven't looked at it properly. Give me a second. Yeah, no, I think mine just says ESP32 Vroom. It's not C6. The smaller ones, like the Super Mini that I have, I believe that is ESP32 C3 Super Mini. But yeah, okay. Uh, so since this one is definitely an ESP32 and it's not a C or an H, so it's probably extensor. I should also do some research on what would happen if I accidentally install the wrong version. Like, is there some check that takes place to make sure that even if I fuck up, it's still gonna stop me from, installing something that could ruin the microcontroller? Now, where was I here? So this is for RISC-V. Here's extensor. As mentioned in the hardware overview, ESP32, ESP32S2, and ESP32S3 are based on extensor architecture. If you are going to target these chips, you will need to use a fork of the Rust compiler for now. You're joking. Hold on, dude. If you're gonna if you're gonna target these chips, you will need to use a fork of the Rust compiler for now. Uh, ESP Up is a tool that simplifies installing and maintaining tool chains required to develop Rust applications. Okay, what happens once I install it? Okay, it installs the Espressif Rust fork with support for Espressif targets. Um, so what would be the situation in the case of RISC-V? To build applications for Espressif chips based on RISC-V architecture, if you're unsure of something, okay, install the proper tool chain with Rust SRC, with the Rust SRC component. Okay, you can wait. It needs Rust up toolchain install stable component Rust SRC. Then install the target. Okay, other components such as Rust FMT, Clippy, or Rust Analyzer are not required, but they are highly recommended. Yeah, that's more for the coding portion of it. If you're not going to use ESP32, ESP32S2, or S3, you are done and can skip the tooling section. can skip the tooling section. Where's the tooling section? Oh, tooling installation. With the toolchain in place, it's time to install some additional tools that'll simplify and enhance the development of Rust applications for Espressif chips. Okay, so this is ESP generate. Okay, then we have ESP flash. I've installed ESP flash. To install ESP flash, execute so and so. Alternatively, you can use install. This is, I think, older information. Alternatively, you can use so and so to download precompiled artifacts from the releases and use them instead. Okay, Probe RS. The Probe RS project offers a suite of tools for interacting with embedded microcontrollers using various debug probes with robust support for Espressif chips. Besides flashing and monitoring, it also provides robust debugging capabilities. If you're unsure whether you need it right now, you can skip the installation and come back later. Espressif devices equipped with the USB JTAG serial peripheral can use Probe RS without any external hardware. For devices lacking this peripheral, you'll need an external programmer like ESP32. Okay, where all is this available? It's available on C6, H2, S3, and C3 revision zones. I probably don't have this. ESP config is a tool to edit configuration options via a TUI using an entirely optional. No, using it is entirely optional. See the configuration chapter for details on how config files are organized and how to manually edit them without using the TUI. Okay. Using ESP generate. This is what I was talking about. This is what's supposed to pop up. Yeah. This is what's supposed to pop up. I'm not sure why it didn't pop up. Oh, it was the next step after. Okay, it didn't pop up because I stopped it. Okay, so this, and then let's say test, and now the TUI should pop up. There it is. So this is the TUI that I was talking about. This gives you like all of the options that you need. It lets you fully customize your entire project setup, and then it'll generate the project based on the parameters that you have provided. Otherwise, you would have to generate or well create that entire TOML file yourself and enter all of the settings yourself, point it to all of the right tools yourself, and stuff like that. So we're gonna get to this, but for now, let's quit. And what was I reading? Oh yeah, I was reading that. Yeah, hold on just a second. Can I go back from here? I think I can go back from here. Yeah, ESP flash, ESP generate, tooling, tool chain installation. So in my case, it's extensor, right? Now, do I have, I think I might have ESP up. No, I don't have ESP up. So I need to install ESP up. But what I don't get is, what all is this? Okay, so Espressif Rust fork with support for Espressif targets, then stable toolchain with support for RISC-V targets. Oh, so then this is gonna give me what I need even for RISC-V devices. Then LLVM fork for support for extensor targets, and GCC toolchain that links the final binary. Okay, all right. Let's do that then. So, ESP Up is a tool that simplifies installing and maintaining the toolchains required to develop Rust applications for these targets. Install ESP Up. You can also directly download precompiled release binaries or use cargo install. Install all necessary toolchains for all supported espressif targets by running so and so. Then on Unix systems, set up the environment variables. See the different methods in. Oh, okay. I can look into that. Windows users don't need to do anything else. Right. What ESP? Okay, I'm done with that. That's fine. Let's start the installation process here. Cargo install ESP up. No, not USP. ESP up. Locked F. F? No, J2. Just so we're not using too many cores. And in the meantime, we can continue reading this. So, using ESP Generate, with all the necessary tools installed, you're ready to create your first. Hold on. So after this is done, tooling installation, ESP Generate, install ESP Generate locked, and then ESP Flash. I believe, yeah, I did install ESP Flash. I also installed Cargo ESP Flash. Um, Hold on. Right. Yeah, you're ready to create your first Rust project running on an Espressif chip. Generating a project. To start, launch the interactive configuration tool by running ESP Generate. ESP Generate will prompt you for your chip and a project name before launching into a TUI with options to configure the project generation process. Okay, adjust the options as needed for your project. See the available options section of so-and-so. There is a small description for each option at the bottom of the TUI. Okay, cool, cool. I'm curious as to what they use to create the TUI. Where is, hold on, ESP Flash, ESP Generate. Oh God, don't do that. Don't do that. Yeah, okay. Right. Did I click the thing? I did. Okay. What was I gonna look for? Give me a second here. Okay, what was I gonna look for? Oh, yeah, let's take a look at the TOML file here. Okay, this is ESP generate, features, dependencies. Anyhow, strum, inquire, clap, so and so, so and so, so. Ratatouille. Okay, awesome. They're using Ratatouille to make the TUI. Right. So we can come back here, and was it here that I was? No, it's from here. We can just go next, next, next. Okay. So what comes after that? Okay, flashing options. There are two options for flashing the code to the target device: ESP Flash, which is a default flashing tool, and Probe RS, which enables real-time transfer based options and allows on-chip debugging. Make sure to enable use Probe RS to flash. Didn't they say that Probe RS, like the support for it is limited? Yeah, I think they did mention that support for it is limited. When using Probe RS instead of ESP Flash, you might want to enable DFMT to print messages and use Panic RTT target as the panic handler under flashing, logging, and debugging. Okay, I'll look into that later. So, generating the project. When you are ready, you can generate the project by pressing S at the root of the TUI. When you save the project, the tool will check for the required and optional tools being installed and shows the results. This may include asking you to install any tooling you may have missed or now require based on the generation options. All right. Running code. Getting your code up and running is as simple as cargo run release. This command compiles your application, flashes it to the target device, and starts monitoring the log output. Congratu- words. Congratulations, you've successfully flashed first Rust your first Rust program onto an ESP32. You're now ready to dive deeper into developing with Rust on the ESP32 platform. Okay, so this is an optional thing. If installed, you can launch the tool from your project's directory by running espconfig. Okay. You can also specify the targeted chip and the config file to use if a tool if the tool cannot figure it out. If a project generated with ESP generate what with a project generated via ESP generate, this shouldn't be needed. See the configuration chapter. Okay, all right. Next, application development. Now that you've successfully run your first program, let's fill in some knowledge gaps and show you some options for some common embedded practices. Application startup and bootloader. Okay, upon power up, many embedded devices will just start executing code from an address in flash memory. Espressif chips are a bit more complicated and require some steps to set up flash memory, a cache, and some other miscellaneous options. For this, we require a bootloader, which is a simple application that sets up the aforementioned operations, then jumps to executing other code. To boot an application, Espressif devices use two bootloaders. First stage bootloader, which is a ROM bootloader. This sets up architecture specific registers, checks the boot mode and reset reason, and loads the second stage bootloader. This bootloader is burned into ROM and exists as part of the SoC and therefore doesn't need to be flashed, nor can it be changed. Oh, the first stage bootloader can't be changed. Okay. Second stage bootloader loads your application and sets up the memory, uh, which is RAM, PSRAM, or flash. The second stage bootloader, whilst um, not technically required, is advised as it allows OTA support. The first stage bootloader only loads applications from fixed from a fixed offset in Flash, and also enables. Yeah, wait, what is this OTA thing? Hold on. OTA was mentioned. OTA is here. OTA updates. Over the air updates is the ability to update an application without the need of production flashing tools. OTA is heavily reliant on a bootloader to handle the switching, replacement, and rollback of OTA images, which is firmware updates. For every bootloader we support, we have a bootloader support crate. As we only support the ESP IDF bootloader right now. Oh, okay. We only have the ESP bootloader, ESP IDF crate. We have a small OTA example in the ESP HAL repository. This example is basic but shows the building blocks to get OTA functionality working. Be sure to check out the documentation, as this example also provides the instructions to create an OTA binary using ESP Flash. Okay. Oh shit, we are almost at the end. Well, I mean, I jumped to this, so there's a couple of other chapters remaining here. We were at application startup and bootloaders, and I thought there would be like more to explore here. Like I thought they would be making us go into like using Espressif uh, or ESP-IDF in order to do non no STD things, but I'm not sure when that comes in. Hold on, let's see what's left to explore. We hope this book has prepared you for building real-world applications using Espressif chips and Rust. We've only scratched the surface. There's plenty more to explore outside this book. Be sure to check out the additional resources if you haven't already. We're excited to see what you create. Be sure to add it to the awesome ESP Rust list, or use this list for inspiration. Okay? If you're keen to contribute to ESP HAL or the ancillary crates directory, check out our developer contribution documentation. Okay. At what point do they? Okay. Let's look at the rest of this. Second stage bootloader, ESP IDF bootloader, building a custom bootloader. Sorry, zoned out. Okay. At the moment, ESP IDF bootloader is the only supported. Wait, they mentioned, okay, for more information about the startup process, check out the ESP IDF documentation. However, note that some aspects may be ESP IDF specific. Yeah, ESP IDF, it just that's like their official thing, which was uh, being used for C++ related stuff, right? That's the framework that was being used for C++ related stuff. I never actually explored this very much in order to even know if this same tool supports, like somehow supports um, Rust as well. Hold on, let's see. Um, Give me a second. Okay, let's see what's under home. Okay, let's go to get started. Espressif IoT development framework. Okay. All right. Okay. Okay. What you need, the hardware, great, great. What do you need, the software, toolchain to compile so and so, build tools, and then ESP IDF. So how are these connected? You have ESP IDF and the toolchain, and then the project, and all this is built, and or all of this is used to build the application, and then that application gets uploaded. Okay. Let's take a look at this. Okay, first steps on ESP IDF. Now, since all the requirements are met, the next topic will guide you on how to start your first project. This guide helps you on the first steps using ESP IDF. Follow this guide to start a new project, so and so, so and so, so and so. Okay. Okay, so we will not be using ESP IDF. I think I'll have a conversation with Gemini about it. Oh, you know what? Let me let me ask the question here. Let's open up a thing over here. Okay. I'm currently doing research on ESP32 Rust programming. From what I understand, there are two approaches. One is the ESP IDF approach, and the other is the no STD approach. Though I don't think it's exactly those two. Like, I might be trying to connect two different things together. Um, but yeah, I guess Gemini will correct me about this. I'm confused as to what ESP IDF even is. Is it a library or a binary or something else? Also, if I'm doing no STD Rust programming for ESP32, I don't need ESP IDF, do I? All right, let's see what the response is. That's a great question, and you've touched on the exact point where most developers get a little tripped up when starting with Rust on Espressif chips. In short, ESP IDF is the official C-based SDK provided by Espressif. Whether you need it or not depends entirely on which flavor of Rust development you choose. What exactly is ESP IDF? Think of ESP IDF, which is Espressif IoT Development Framework, not just as a library, but as a complete operating environment. It is written in C and is the industry standard for developing on ESP32. When you use ESP IDF, you aren't just writing code for the hardware, you are writing code that runs on top of RTOS. I didn't realize that. Okay, it's not bare metal. Right, key components of ESP IDF. Free RTOS manages multi-threading and scheduling. Hardware drivers, pre-written C code for Wi-Fi, Bluetooth, I2C, SPI, etc. Networking stacks, full TCP/IP and TLS support. build system uses CMake and Ninja to compile and link everything. The two Rust approaches. In the Rust ecosystem, we split these into the STD approach, which is a standard library approach, and the no STD approach, which is the bare metal approach. Give me a second here. Okay. Right. The STD approach uses ESP-IDF. In this mode, your Rust code acts as a high-level wrapper around the ESP-IDF-C libraries. How it works: you use a crate called ESP-IDF-sys, which links your Rust code to the ESP-IDF-C binary. Why use it? You get access to the full Rust standard library, including threads, collections, and the mature Wi-Fi Bluetooth stacks provided by Espressif. The catch: your binary size is larger and the build process is more complex because you need a C toolchain instead. Then we have the no STD approach, which is a bare metal approach. This is the pure Rust. This is pure Rust. You are writing code that talks directly to the silicon registers without a middleman. How it works: you use the ESP HAL crates. Um, by the way, for anyone who doesn't know, HAL is hardware abstraction layer. Then, do you need ESP-IDF? No. In this mode, you completely bypass ESP-IDF. You don't need free RTOS, and you don't need the C SDK. Why use it? It's incredibly fast, has a tiny memory footprint, and feels like true embedded programming. The catch: you lose the Rust standard library, you have to manage memory more carefully, and Wi-Fi/Bluetooth support is still being matured by the community via the ESP Wi-Fi crate, which now I think that's the ESP radio crate, because they've consolidated Wi-Fi, Bluetooth, and maybe a couple other things into one crate. I think so. I don't remember. I remember reading about this. They had like some kind of table in which they were mentioning that there's support for this and no support for that, or partial support for this and whatever. Okay, which one should you choose? Choose STD if you are building a complex IoT device that needs stable Wi-Fi, HTTPS, or MQTT, and you don't want to reinvent the wheel for networking. And choose no STD if you are doing low latency work, need to save every byte of power/RAM, or simply want the pure Rust experience without any C dependencies. Yeah, okay, cool, great. Now, what was I doing? So there's ESP up. Yeah, let's do ESP up install. Okay, checking Rust installation. Installing Extensa Rust toolchain. Installing RISC-V Rust targets for the stable toolchain. Installing GCC. Installing Extensa LLVM. Okay, all right. Hold on, let me just... Okay, all right, cool. Oh, wait, there was something to do with ESP up, I think. Yeah, there was something to do with ESP up. There was some information surrounding ESP up that I needed to look into. Where is it? ESP up. ESP up is a tool for so and so, so and so. Okay. Environment variables. That's what I'm looking for. Okay, download complete. Installing Rust component for Extensa Rust toolchain. Oh, you know what? I can ask the question here. I plan on doing no STD. Just an FYI. So I'm probably not going for ESP IDF. That being said, I have another question. So what was I going to ask? Oh yeah. So um, the ESP32 that I have uses the Extensa architecture. The docks for the docks or the Rust. Hold on. What the fuck is this book called again? The Rust on ESP book mentions that for Extensa devices, I need to install. Oh God, did the installation fail? Oh God. Okay, hold on. Yeah, I just ran out of space. So give me a second here. I'm getting a warning that the system is low on space. It failed. That, oh God. I'm gonna have to run this again. Yeah, wait. Let me do something here. Actually, first of all, let me do trash empty. I don't remember how much is going to be freed. Give me a second here. Oh, did it free something? Okay, so it's showing around 1 GB free here, and that is slowly going down. Is it freeing or like, hold on, let's wait and watch. Yeah, it seems to be writing. Yeah, okay, okay, okay. All right. It's installing, but I think it's about to run out again. That is wild. Okay. I need to free up some more space here. Installing Rust SRC. Oh, I think this is still emptying the trash. Yeah. All right. We should be. Yeah, we should be good now. I think so. Oh yeah, there it is. Now 3 GB is free. Okay. Done. Awesome. Now we have a good amount of space. Let me just do this. Don't open that. Okay. Yeah. Now, what failed up here? Installing RISC-V target. Okay, installing this and then uninstalling that. Installing RISC ins installation for RISC-V target failed. Retrying error so and so so and so. Okay, installation. Okay. Installation for extensor Rust failed. Wait, RISC-V failed. Is it gonna retry the RISC-V thing? Okay, uninstalling extensor tool chain. You know, I'm gonna run this again. just because. Okay, let's read that. Okay, installing the Espressif Rust ecosystem, checking Rust installation, installing RISC-V Rust targets. Okay, previous installation of LLVM exists, reusing this installation, installing GCC, Extensa Espressif ELF. Previous installation of GCC exists, reusing. Previous installation of Extensa Rust exists. Creating symlink between this and ESPC lang. Okay, so now I want to see. Actually, yeah, how do I see all of the versions that I have installed? I forgot what the thing was. Show active and install tool chains. I think that might be it. Well, there's tool chain itself. Um, yeah, let's try tool chain. So Rust up tool chain, because I have another one that I use for like general programming. Back up. What did I do wrong there? Yeah, it says commands tool chain, right? Oh, I need to give some. Okay, tool chain list. Okay, so I have stable, nightly, and then ESP. Right. So that's what. Sorry. That's what I was confused about. Now there's something else that I want to ask here. Um, the Rust on ESP book mentions that the extensor devices I need, that for extensor devices I need ESP up, which installs the necessary tool chain, including the Rust, including the specific Rust compiler for um, for ESP32 and a specific LLVM version as well. Um, there's two things I'm wondering here. One is when I do cargo run release on my ESP32 project, how does it know which Rust tool chain to use? Also, since I now have multiple tool chains, stable, nightly, and ESP, would this somehow cause issues with regular Rust development? Okay, so this is a very sharp observation. Managing custom toolchains can feel like you're about to break your normal Rust installation, but the good news is that the Rust ecosystem was designed from the ground up to handle exactly this scenario. Since you're targeting the Extensa architecture, ESP32, and S3 and S2, you are using a forked version of the Rust compiler because the official upstream Rust compiler doesn't yet have full native support for Extensa's specific instruction set. How does Cargo know which toolchain to use? When you run Cargo run or Cargo build, Cargo doesn't just guess. It follows a strict hierarchy to determine which compiler binary to execute. The Rust toolchain.toml file. Most ESP32 project templates, like those from ESP Generate, include a file in the root directory called rusttoolchain.toml. It looks something like this. Okay, when you enter that folder in your terminal and run a command, rustup, which acts as a proxy for all Rust commands, sees this file and automatically switches the active toolchain to the one named ESP just for that project. Oh, okay, it switches the active toolchain just for that project. Okay, the resolution hierarchy. If there's no toolchain file, rustup checks in this order. It checks the command line override, like cargo. Oh, I can specify the toolchain when calling cargo as well. Okay, so then that would force the ESP thing. Okay, environment variables. I just remembered that we were supposed to look at that in on the GitHub thing. Requirements, install so and so. Well, I didn't install this, but like I'm pretty sure at some point in the past I have installed a bunch of these. I've definitely installed. I have GCC. I've probably also installed it. Um, I have build essential. I'm pretty sure I have curl, and I think I installed package config with some other tool that I was trying to install. Now, they mentioned something about environment variables. After installing the toolchain on Unix systems, you need you need a source file that will export the environment variables. This file is generated by ESP up and is located in your home directory by default. There are different ways to source the file. Wait, they said you need to source a file, as in activate those environment variables. Source the export file. Wait, this is a shell script. Source this file in every terminal. Create an alias for executing this. Yeah, this is what I was assuming they were going to ask us to do. Then add the environment variable to your shell profile directly. I was assuming they were going to ask us to do exactly this, but like if all we have to do is execute this shell script and that's going to do the job for. I mean, I can add this myself as well. I'll just take some time to read it and understand what's going on, and then I can add it myself. Basically, I'll have to edit something. And usually, when they say to set environment variables, then generally you're supposed to go into one of these files. In my case, it's bash rc, and you create the environment variable there, and also, of course, what it points to, and then you just source that file. The whole idea behind sourcing the file is like reloading that file. So any changes that you've made in that file, they are now part of your terminal. So you will then have the environment variable present in that session of the terminal. Alternatively, you can also just open a new terminal session, and that new terminal session will have those new environment variables that you had entered into the bash file. But yeah, okay. Give me a second. All right, so we made some progress here. Now, give me a second while I look for somebody to raid. Kickstarter Live. That's interesting. Okay, then Cozy. Okay. Study with me. Hell yeah, hell yeah. What is this person doing? Non practicing intellectual from zero to data analyst. Okay, staring at a screen and occasionally writing. I'm trying my best to motivate myself to do things. Let's check this person out. I don't know if there's like, okay, never mind. Uh, that's a verified accounts only chat. Okay, give me a second while I keep looking. Right, who is this? Follower only chat. Never mind. Uh, Learning math and calc, trying to become less of a noob, less of a noob at it each day. Okay, let's check out this person. Okay, you know what? I think we'll go check this person out. Assuming they don't have any settings that prevent um, small raids or raids in general. They have disabled raids. Never mind. Oh, you know what? We're gonna go check this person out. They are they are writing something. Yeah, they're writing something. Let's go check out their thing. Their name is, what is that? Fate Magnet. I hope they don't have any settings, dude. Oh, okay, cool. So we're gonna go check out Fate Magnet. Um, they are writing something. I'm not sure what. But yeah, that's gonna be it for today's stream. We made some good progress here today. We mainly did a bunch of reading and installing the tools that were necessary for doing development, doing ESP32 development. However, progress is progress. I mean, you know, it was still, we were still studying something and we were getting some work done. Um, yeah, let's see what the next stream is. Hopefully, I'm gonna be able to keep this streak going at least until New Year's. I'm gonna be able to stream every single day. I'm hoping. Let's see if that happens. And who knows? Maybe if I've read up enough, then tomorrow we might do more ESP development. I don't know. Let's see. ESP Rust development, I should say. Uh, let's see. Let's see. If that is going to be the case, then I'm probably also going to spend some time. Oh shit, the raid time is about to run out. Okay, I hope you guys have a nice day, and I'll see you all next time. Peace.